Figure shows a combination of four identical bulbs joined with a battery, and compare the brightness of the bulb shown. What would happen if A fails so that it cannot conduct? What happens if C fails? What happens if D fails? Look, if A fails, if this fails, then the current doesn't go here, okay? Because the circuit will become open. And when it will become open, B won't light up. But there will be a difference now. You see, the if I were to redraw this now, you can always redraw a circuit to understand it. Connecting wires really don't make a difference. You can always extend the connecting wires. So I'm going to redraw this to make it to understand it better. So it's going to be like this: A, lamp B, lamp C. I'm just trying to extend this line. Then I will connect the battery like this because it is connected to this point. I can just stretch it and take it here like that. Okay. And then connect B and D, B and D here. And I notice a very stupid thing. I notice that this point and this point are connected. So what does this indicate? It indicates something very strange, that current will go from here. It will have two paths. Either it can go here or it can go here. It will never go towards this path, because it is finding something which is which is consuming energy. Here it's the lowest energy path, so it will go here. So actually D is not even working. It is short circuited. Okay, so the bulb D has a wire connected across it, short circuit. So the potential difference is zero and it doesn't glow. Now, how do you understand? So you can also, I'm just removing D. D is not this. D is not part of the game. It's not working. If D fails, we cannot detect this event because D has not going initially also. So there's no effect. Now, how do we detect this? You see, you what you do is you let's take a number here. Let's say this is 0 volts and this is less 6 volt battery. So this will be 6 here till it encounters a resistance or a lamp. It will always remain 6 because the energy has not been dissipated. Connecting wires don't. And what 0 here, 0 here, 0 here, 0 here, 0 here, 0 here. So it won't move. But there's no potential difference. This bulb won't light up. And this is 0. It will just go like this. So now it is connecting like this. Actually, the circuit is like this. Now, if a what is this? This is two resistors R1 and R2. And what is this? This is R3. So effectively, this is a parallel connection right now. And this will be less resistance. If it goes away, then this also goes away. The resistance will increase. And then what happens? You see, V is equal to IR. If the resistance increases and the voltage will also increase, and I to is just one this thing now, and the potential, all the energy will be consumed here only. So the bulb will glow more brightly. And so this is about, and what if C breaks? If C fails, then A and B will glow equally brightly, but they will glow brightly, but equally brightly. So this is how you see things. Okay, you can read all the circuit. You should look for short circuits. They play games. And third, you should know what happens in one fails. The energy is being consumed in one bulb. Here it is equally divided, and energy is VI. P is equal to VI. So think of voltage and current. Think of a bag of the electron. So the bag is now being consumed initially here A and B. I told you now each electron is carrying a bag full of energy. So all the energy is being consumed here only because this is the only way it will go. And if here it was, if this goes away, then it will be equally consumed in both.